for giving me the chance to talk to you today. Unlike Alec, who just talked to you about the thousands of installations that he's personally affected and implemented, I'm going to tell you that I've affected 0 installations so far. And one of the really important things that I want to convey as HP is that we come into this with a real sense of humility and a sense of recognition of what's happened over the last 20 years. Amazing innovations, absolutely inspiring. What I want to share with you today is a little bit of a perspective on what our mindset is as we come into the market. As you see from this slide, my name is J. Scott Schiller. Just to clarify any confusion there, my father's name is Joseph, my grandfather's name is Joseph. My name is actually Joseph. My mother kept calling out Joseph, and after a while everybody would come, and so she said, "You're going to be Scott." So I go by that. It's not intended for pretense. So, what I want to share with you today is, number one, how do we look at the opportunity for 3D printing or additive manufacturing? I want to share with you that I think it's not about 3D printing or additive manufacturing. I actually think that the major thing that is the underlying megatrend is digitization, and that there is a major transformation working its way through. It's actually already worked through a number of different industries already, and now it's going to work through the production and manufacturing of tangible objects. I'm going to tell you where we are with Multijet Fusion, and then finally I want to talk a little bit about our views on industry collaboration, and specifically how that relates to where this industry is in its evolution. So first and foremost, everybody asks, are you going to make consumer products? Are you going to have the razors and blades business model that I guess people have come to associate with the name? And the reality is, no, not at all. Where we see the opportunity is in the commercial space for sure. And we see this technology as one that will be completely transformational, right? And what that means is that there is a wave that will roll through that will transform industries and how things are done. And we know this not because we've done research, not because of what we've observed, but because of what we've done in other markets. So what I'm going to share with you is a little bit of an analogy about how this has played out in another market, and then what that might mean for this market as we go forward. Before we get too focused though on moving everything to digitized production, in our view, and I think the view is shared by many, it all starts with the process of innovation itself. It starts with the design. And what we see is, it's funny, I've heard people say that their belief is that the market for prototyping is saturated. I don't think it's begun yet. I think there's so much opportunity to completely transform the way companies use this technology, the degree to which they use it, the depth to which they use it. There's tremendous opportunity there to increase growth. But there's some things that are going to be necessary in order to drive that adoption. So what I'll talk a lot about today is what we perceive as a gap between design intent, what the designer is trying to do, and what actually is materialized out of the systems today. And in many cases, there's amazing technology for printing or producing in an additive manufacturing process. But there's still some real challenges in the flows of getting from the creative intent to what actually comes out of the machine. And we have ideas about what needs to happen there. If I was to make an image that was, kind of a view of what we think this gap between design intent and printing looks like today, it's something like this. It was once effective, it was once adequate for what it was intended to do, but over time it's really outgrown its capabilities. And what we need to do is move in the direction of something that is built with architectures for the future. And so that's really where a lot of our focus is. Now, as I said earlier, I'm going to say it's not about 3D printing, it's about digitization. I'm going to give you a little story behind that. And in the end, though, the observation is that when things are in digital form, when they're in the form of ones and zeros, they're the most flexible, the most malleable, optimizable, transmittable. You can do so many things that you can't do with physical things, or you can't do as easily. So the idea of what this does for you is it brings a number of benefits, and I think they were even mentioned in the previous presentation. First of all, you can get to setup immediately, right? So rather than having to go through very long development cycles for doing molds, castings, and things like that, trying to get into the priority queue of getting that work done, now you can do something instantly. The second thing is that you can move supply near demand, and by virtue of that, you can make things much more scalable. In the case of the example I'm going to show you in a minute, we can prove that you can completely eliminate risk. You can have demand happen, you can have payment happen, and then you can have production and delivery happen. That's a complete transformation. And of course, out of that, then things become more valuable. So rather than everything being made for a mass market, such as what used to be the case for movies, for books, for TV, what you see is this massive proliferation of interest because people can get exactly what they want. Personalized, customized, targeted, etc. Things become more valuable. When they're more valuable, they're not wasted.
One book, or we could print 10,000 books. It makes no difference. And after those 10,000 books, if the next job has 2 books on it, they just come flying right out after it. 1, 10,000, 5, 10, 20, it doesn't matter. They just come out, one after another. Not one wasted sheet in between.
So take a look at that machine. Keep that in your mind for a minute. As I said, I haven't been responsible for thousands of implementations of 3D printing, but I have been responsible for many implementations in the traditional printing space. One of the things that came as a result of the internet was businesses like Amazon. When Amazon came into the world, you had the idea of virtual inventory, almost infinite inventory, and they could fulfill that. As they provided that service, that completely changed what was necessary in the back end to fulfill. And the demand dynamics changed completely. As those demand dynamics changed, you needed systems on the back end that could deal with that. So I spent the last 10 years of my life building a business that was focused on mass customization. That machine runs 1-ton rolls of paper at 800 feet a minute in full variable data. Now, I'm going to get a little nerdy here for a second, but I want to give you a sense of the data intensiveness of this technology. Strangely enough, the manufacturing of books is the bleeding edge of data pipelining. So that machine has 200 print heads in it, and those print heads each have 10,560 nozzles. Each one of those nozzles can fire 6 or 9 picoliter drops at a rate of 48,000 times a second. Now, we don't run them that fast. We run them much slower, down around 28,000 times a second. So a little quick math. 200 print heads, 10,560 nozzles, 28,000 times a second. All of those are ones and zeros. And then what we have are these big, huge fiber optic cables that feed these machines. And what is being produced can be delivered into that machine at the very last second. And ultimately, what that enables is business responsiveness. You can change everything at the last second. And that's what's going to happen in this space. But in order for that to happen, it needs to be more scalable, right? The solutions, the technologies, the capabilities, the standards, all of these things need to move up a level. And if I convey one message, the view of HP is that we have the opportunity to help the industry advance. And of course, as the market grows, we will want to participate in that. But really the message I want to convey is the view of HP is it looks a lot like the market did for traditional printing when the PCs first came out in the 80s. When everybody got a PC, then they wanted a printer. Those were some miserable machines to use in the 80s. But over time, they got to be something that you just took for granted. They just work. You push a button, it works. And what we need to do with this industry is do a very similar kind of thing. In this market for books, the way things work traditionally is that it was a massively inefficient supply chain. To give you a sense of that, the way it works is a consignment-based system. This mostly applies to the US. I don't know how different it is here. I'll give you that caveat. The way it works there is that the publisher makes a bunch of books. They test and they think they know what the demand's going to be, but the truth of the matter is they have no idea at all. The biggest sin in retail is to have a customer that wants a book and it's not there. So what do? They fill up the channel with inventory, they push it all the way out, it goes out, it sits in the displays, and then it isn't sold, and then it has to come all the way back through that system. And as a result of that, that's all carrying costs, inefficiency, and ultimately, it's thrown away. 30%, and actually the truth of the matter is if you really dig in, it's much higher than that. So that was a big opportunity for us. And so what we saw was a great way for HP to take its technologies that it used for other markets and help drive better efficiency in these. Now, I'll be very candid with you, speaking kind of personally. After spending 10 years doing that, building machines that looked like the scale of what you saw there, that was a 2-story machine that was extremely high volume. It was truly a machine of mass customization. But I feel like those 10 years were my training for what's going to happen in this space over the next 10 years, 20 years, 30 years. There's a lot in front of us. So this was a great opportunity for us to have an impact. Now, the question is, who was going to adopt this technology? Was it going to be the big entrenched players who had proven that they could dominate the market and had driven all the economies of scale? Do you think that's who it was? Truth of the matter was, it was not the really big players, it was the second tier, the third tier, the guys who were a little bit hungry, the guys who thought they could find an angle to make a change. And so, this is why I say, we don't say this because we think it or we theorize it, we say it because we've done it. In the case of a company that I absolutely love in Boston, Courier Corporation, they started working with us. They had actually tested digital printing technology in the early 2000s, but they just felt that it was not ready for prime time. It wasn't quite there. These are true engineers and true manufacturers. They started working with us, and the thing that we did well is that we listened to them. Now, making a machine that you saw in that one image was not a natural thing for HP to do. That thing was a massive machine. It's the size of a bus. But what they said is, we need that kind of mass scale, we need that kind of productivity, we need that kind of quality to enable mass customization to become a reality. And so as a result of that, we worked with them using their inputs, very closely working with them, and as a result of that, we were able to really transform their business. Because of the fact that they are also a publisher and we kind of had a closed loop, we were able to prove unequivocally that 30 to 40% of everything they've made that went into the garbage was now able to take 73% of that out. This is just over a period of a few years. They've done much better since then. Inventory cut by a third, warehousing space cut. And all of these numbers were just the preliminary numbers after the first implementations. I can tell you today they've gone a lot farther. And what we talk about when we talk about digitized production is the two things. One, you capture more value. So if they take all that waste out of the system, they don't spend as much, they don't waste as much, they are more efficient. The other thing is that they create new value. They make products that weren't otherwise possible. One way that happens is that they can take, in this case, titles of books that the volumes were so low that they couldn't really justify keeping them in inventory. But in fact, in virtual inventory, you can keep it forever. And so they were able to go back to companies like Amazon and others and say, you know what, every title is still in production. If you need it, give us a call. And over time, they started becoming so fast that the turn time, the responsiveness, became so fast that you could actually have a situation where there was demand, payment, and then print and fulfillment. And that is a complete transformation. Now, the question is, what happened? So, I told you there were some big industry players in this industry, and there were two really big ones. One was Quad Graphics. Quad watched what was happening, and they also saw the evolution of the world in terms of these digitization trends, and eventually reached the conclusion that this was absolutely the way of the future. And as a result of that, they decided they were going to make almost $500 million investment to completely change the way manufacturing was done. That is a big, big change. Now, we started this business in 2009. We got rolling in earnest in 2010 and 11, right? It takes a while to get businesses going. This all happened in a total of about 5 years. And when this happened, Quad decided they were going to buy 20 of those giant mass customization machines, and then after that, acquire Courier. Because Courier had perfected the art of digitized manufacturing. It's not enough to have the machines, you have to understand the processes. You have to understand the workflows. ERP and everything changes. And so they thought the way to accelerate that would be to acquire Courier. That was so threatening to their primary competitor that their primary competitor got in a dogfight with them over who had the privilege to buy the second or third tier player. That's the effect that really embracing digitization of manufacturing can have. it's played out. And so as we look at this space now, what we see is absolutely the same thing is going to happen. You know, what we say internally is, it's not if, it's really the science needs to be behind when. And so now with that, I'll transition to a little bit more about what we're doing in additive manufacturing.
HP has been on a mission to disrupt the process of innovation and advance the state of the art of 3D printing. By bringing HP's proven expertise in digitization technology to the design and manufacturing industry within reach of everyone. HP is engaging the most brilliant minds through an open innovation platform, so developers, creators, makers, and designers can all realize their full potential. With our 3D printing technology and your vision, together we can launch the next industrial revolution.
So, as I mentioned in the beginning, the focus for us initially is very much on the commercial side. We will serve the maker community, but mostly through service bureaus that focus there. We will serve the professional markets. We will also definitely work with enterprises to help them adopt this into a broader scale. The thing that's really cool for us internally is that A, we're all engineers. B, we have tons of model shops. We do all of this stuff in-house. We have them all over our company. And so now we can really quickly iterate and understand what this technology can do. And so this is a market where we have a lot of deep roots. Now the interesting thing that I'll tell you is that this summary here, this incredibly technical summary of what it what's necessary to drive adoption of this technology or to remove friction from the process, came from other businesses. It's not complicated. Speed, quality, cost, right? Just keep working that over and over and over and over relentlessly. Now the one thing I will say is that in this market what we heard was reliability. Please give me a machine that I can predict what the outcome will be. So we took that into consideration. Now the question is, how do we do that? With our technology that we use in this space, you'll see in just a second, we'll be able to bring big breakthroughs in speed and quality. And we will continue to work on those. An idea I would share with you is, the first machine out is not the end point, that is the beginning. And we relentlessly work on these challenges over time. And we have a big set of engineering capabilities and material science that will deploy against that. But the question is, given the amount of white space in front of us in this space, right, all these different verticals, all the potential that we all see, and we're just agonizing to get at that opportunity, what is the best way for us to pursue that? As we looked at this, we said, well, reliability is super important, right? I mean, that, and of course, it's our brand name. This is what we're known for, this is what we do, so we really have to protect that. The easiest thing for us to do, the most natural thing for us to do would have been to just lock it down. If you can control it, then you can characterize it, you can build the data necessary, and you can make it very predictable. And we looked at that and we thought very hard about that. But the truth of the matter is, what we also saw is that there's a lot of developers, material science companies that would like to be participating in this market. But right now they really couldn't find a way in. Given our material science capabilities, one mindset might be that we should just do this all ourselves. But another might be that we should make an amazing platform that allows a lot of other people to innovate on that platform. That's the mindset that we have. And so as we look at how we can help drive adoption, how we can help expand the market, what we believe is that open is really the right way to go. And so what we're doing is making it so that our system will allow materials from third parties to work on our system as a platform. But that in and of itself is not enough. The materials is not enough. The other thing that I mentioned in the beginning of the presentation is this big gap between design intent and what comes out of the machine. It's going to be very frustrating for us if we make this really amazing machine with amazing capabilities, but you can't get there because the workflows aren't there. So that needs to be another area where we put a great deal of energy. And so as we think about that, we'll be looking at how we could work in more of a standards-based and partnering mindset in terms of our strategy for workflows.
HP's Multijet fusion technology produces high-quality, functional parts at a production speed which is 10 times faster than today's competing products. Unlike the slow point processes of some current technologies, HP's Multijet fusion technology processes parts in 2 fast area-wide passes to achieve top-speed part production. The process begins by applying a layer of material in a work area. Then, in one continuous pass, we print liquid agents across the full working area using HP thermal inkjet arrays. In the opposite direction, we combine the layering and energy fusing into one continuous pass. This HP proprietary architecture, using HP's thermal inkjet arrays, is capable of printing 30 million drops per second along every single inch of bed width. To achieve part quality at speed, HP invented a multi-agent printing process. In this process, a fusing agent is applied on a material layer where the particles are meant to fuse together. A detailing agent is applied to modify fusing and create fine detail and smooth surfaces. The area is exposed to energy, and reactions between the agents and the material cause the material to selectively fuse together to form the part. The process is then repeated until a complete, high-quality, highly functional part has been formed. This is how HP's proprietary area-wide processing compares with today's popular point processing technologies for building functional parts. In the time it takes these slower point processes to build 1,000 parts, HP's Multijet fusion technology would have created several thousands of parts. Using HP's proprietary multi-agent printing, the HP Multijet fusion technology achieves new levels of part quality at these breakthrough speeds. Beyond the first product, HP's Multijet fusion technology enables the world to realize the full potential of 3D printing in fully functional parts. Taking advantage of HP's in-depth knowledge of color science, HP's 3D printers could selectively print a different color at each volumetric pixel. A single 3D printed part could have literally millions of colors. But more than just color printing of functional parts, the future of HP's multi-agent innovations could enable realizing the full potential of 3D printing. At each volumetric pixel, or voxel, HP's transforming agents could control surface texture, wear, and friction. HP transforming agents could control the translucency of each voxel. HP transforming agents could allow one to optimize the strength and stiffness in portions of a part and to print elastic voxels in other portions of the part. HP transforming agents could be used to change the conductivity of certain voxels. HP transforming agents could also be used to enable the printing of new advanced materials or enable emulating different materials at each voxel. HP's Multijet fusion technology could enable design and manufacturing possibilities that surpass the limits of our imagination.
So I hope that helped explain the technology. It's a simple framework, and yet it's incredibly powerful and diverse. So think about the variables that we have at our disposal. One is the materials. If we make the materials open, then there's going to be an enormous number of potential permutations in terms of the materials. The materials can be in a variety of different forms. What you'll see what we're doing right now is nylon powder. It can be a powder, it can be a paste, it can be a slurry, it can be a variety of different forms. Then you have the machines, or the printheads that are generating the chemistries. Now the printheads that we're using are 21 micron resolution between the nozzles. We actually have other generations of that technology that are developed and finalized and being used in other markets that double that resolution. Those are in other markets right now. When we're able to take advantage of that capability, then we'll be able to use that on this platform. And as it works out, it's already paid for, so one of the other businesses paid for it. So we get to leverage that. That's great. Then you've got the agents that are ejected into the bed of the material. Now those agents are really important because what you see there is not a binder jetting process, which people frequently associate with anytime you're doing inkjet. In this case, it was a thermomechanical process. We eject a chemistry that differentially absorbs energy, and as a result of that, it fuses, and other places doesn't fuse. We actually dropped another chemistry that inhibits fuses. It stops fusing. So you can have very high control of bleed in the XY direction, but you can increase the thermal bleed in the Z direction. Better bonding between the layers while having very high accuracy in terms of XY direction. So that's very powerful. The energy source that we use is light. That light is a mechanism of radiating energy into the bed, but it could be lots of different things. So you start doing the permutations between the materials, the form of the materials, the print heads, the agents. The agents can be thermomechanical, could be reactive, and then the energy sources. The number of possibilities, I mean, they say it at the end and it sounds like hyperbole, but it really exceeds my imagination at least. And given that, what we believe is that we need to take an open approach because there's just too many possibilities there. We can't do it all ourselves. So I wanted to stop with just an example of the parts to make a point. So on one hand, one of the great things with this technology is that it's very strong mechanical parts, and I think many of you have seen a video where we hang a car in the air with a link that we printed just using thermoplastic. In this case, what you see is color. Now the interesting thing about color is don't think about it as colored parts, think about it as an analogy. What color represents is the ability to vary things at the voxel level. And so you see some examples there. In this case, what you see is the little snowman there relative to a dime. And what I would have you look at is that the orange color of the nose, the tip of the nose, how much detail is there, and that's a process color, which means that it's a function of cyan, magenta, yellow, and black that has to be converged in such a way that you perceive orange. Think of that then as something that you could use to create a gradient. So, one of the big challenges that we have is we have a technology. We get to use our color technology and port it directly into this. That sounds great. That's a problem. If you look at this, what we have here are samples where if you cut them in half, you would see that it's color through and through. And it's gradiating color. And the challenge is that there's no software that allows you to do that. Both in two ways. One is that there's really not a way to do that in terms of representing in the volume. But the other is just making it so that the user of the design software is able to abstract back far enough to take advantage of that capability. These are the kind of things that we're working with our partners in the workflow space to drive advances in. This is why we made an announcement to the world that we were coming 2 years before we were going to put a first product in the market. Normally that's not a strategy that people would recommend. But the truth of the matter was that we have capabilities and we need the whole system in order to be able to take advantage of those capabilities. So, a couple of things that have happened along the way since we've made our announcement. One is that there has been the formation of the 3MF Consortium. You're going to hear a lot more about that today. The people that will represent that will do a far better job than I can technically. But fundamentally, what you should see is that it is intended to be an architecture for the future. It is intended to be something that is open, and it is intended to be something that is adopted very, very widely. And you'll see already the number of people that have joined the consortium give great confidence that this can become a standard. The other thing that we did is we announced a partnership with Autodesk for their Spark platform. This is an amazing open system that allows you to get from the design tool itself in the AutoCAD world all the way through to the machine and get the true intention out of the machine without creating errors, without introducing loss of fidelity along the way. These are the beginning steps. There's many more that need to happen. So, just to close, a few key points that I want to emphasize and I hope came through the discussion today. One is that we need to collaborate. And somebody told me yesterday, HP coming into this market is like, oh, here comes this big elephant, right? And it's funny for me to hear that, because I spent the last 8 years doing a startup in HP, and it's no different inside a company than it is outside. We have investors, they're impatient, they get grumpy, and they make you work very hard in order to live up to the growth expectations. And this business is far more visible and prominent in HP. And so there will be incredible focus there. But we are still a startup, and as a result of that, we're humble. We know we need to listen to the market. The second thing is embracing open as a strategy holistically throughout, whether it's the materials approach or it's the software. Fundamentally, it's a philosophy that we will be embracing. Business models that help the industry grow, and just to address the question of, is it a razors and blades business model? There was a time when that was the necessary model to expand the market as fast as possible. That's not what's needed here, and that's not our mindset at all. What we will do is what's appropriate in a commercial space to drive adoption. And lastly, partnering to develop the necessary applications and tools. I think you saw from the example there. So with that, I'll close here, and thank you very much for giving me the time to share our insights with you.